relationship with each other where Tycho Brahe is absorbing all this data, but he won't show it to Kepler. He just sort of spoon feeds him little bits and pieces of things. And Kepler begins absorbing this data and particularly starts focusing on the orbit of Mars because they can't figure out, nobody can get the orbit of Mars right. So he starts focusing on that problem. And it was working out the orbit of Mars that led to Kepler's discovery of the 3 laws of planetary motion. And the 3 laws then of planetary motion. And then there's other hilarious escapades regarding.
Is that during the Copernican thing or the Newtonian?
Now we're in the Newtonian.
Okay.
All these guys are part of the Newtonian revolution. Man interested in money and riches, and Kepler would write letters to him and say, hey, I've heard you've invented this telescope. I want to look at it. And Galileo would just not answer him. It was very rude. And so Kepler, I think maybe one period had the use of a telescope, but only very briefly. All of his data is based on raw eye observation, his and Tycho Brahe's data. That's an interesting thing. So Kepler begins to focus on the orbits of Mars, and he begins to realize that the first law of planetary motion is that planets move elliptically. They do not move, as Copernicus wanted them to move, in perfect circles. They move in ellipses. Now an ellipse is simply composed of 2 parabolae that are joined end to end. Which is interesting because for Galileo, if you sort of shot a ball out of a cannon at a 45-degree angle, it will make a parabolic arc. For Galileo, who was obsessed with studying falling bodies, a parabolic arc was the archetype of all motion. It was the best earthly motion could get to actually reaching, as it were, for the stars. So all of his work comes out of the study of falling bodies. He's rolling these balls down inclined planes and then trying to smooth the planes out so he can reduce the amount of friction, and he keeps rolling the balls down, and there's some controversy about whether he actually dropped things from the Leaning Tower of Pisa. He probably did not. It's probably a mythologization of him rolling these balls down inclined planes. And then he works out what is said to be the first law of physics, which is namely that all bodies fall with the same constant rate of acceleration. Aristotle had taught that heavier bodies fall faster than lighter ones, because heavier bodies are trying to get back to the Earth, which is heavier than everything else. But he figured out that actually, if you drop two bodies in a vacuum, they'll fall at exactly the same pace. And this was only empirically shown when the astronauts went up on the moon, right. And you actually see them dropping a feather and a penny, and they fall at exactly the same time. So this man is working these ideas out in Italy, and Kepler's in the northern world, working on the laws of planetary motion. So we have terrestrial motion and planetary motion. The two men aren't communicating at all with each other. There's the first law of planetary motion, and the second law is that the planets sweep equal areas in equal times.
Say that again?
They sweep equal areas in equal times. And visualize it, all it is along that ellipse, as the planet gets into the tight area of its orbit here, it's got to move faster to cover an equal area of time. And it moves slower as it gets out here. And it moves faster when it goes along the sort of curves of the ellipses, and it uses geometry to work all this out. So the planets, in other words, don't move at the same rate as they go along their orbits. This isn't perfection here. This is all, he's beginning to work all this out, that everything in the heavens is imperfect, not perfect at all. And then the third law, which was worked out much later, is simply that the further the planets are out away from the sun, the slower they move, the longer it takes them to make their orbit. Those are the three laws of planetary motion that Kepler worked out. And Kepler really is the man responsible for the death of the Anima Mundi, more, I think, than anyone else. And because he says, my aim is to show that the celestial machine is to be likened not to a divine organism, but rather to a mechanical clock. And he says the way in which this will happen is, illustrating with these laws, you realize that the planets don't move in perfect circles at perfect uniform speeds. So why is it that they don't? Well, he says if the theory is that they move this way, if they have souls and they're alive, then they should move perfectly. But because they don't, they must not be alive. Therefore, if we translate the word soul for a single force, we will begin to arrive at a new kind of physics that's mechanistic and that accounts for the phenomena. So he says there's a force that radiates out from the sun that gets weaker on the planets the further they are out from the sun. And what that force is, he wasn't sure. It's gravity, actually, but he didn't know that it was gravity. And he says, well, it's electromagnetism, because Gilbert, who has been working on the theory of magnetism. And so he thinks that this electromagnetic force is kind of pushing the planets along. And the further they are away from the sun, the harder it is for the force to reach them. So that's his vision, and that announces the death of the Anima Mundi, because these planets are no longer being turned either by angels or moving as the result of living souls. They're like a machine. They're mechanical. And they are most analogous to a mechanical clock. So now we arrive then with Isaac Newton, who ties all this together in a neat little bow by essentially fusing together the terrestrial laws of Galileo with the celestial laws of Kepler. He sort of performs the Mercury job, the go-between here, by bringing the two men's worlds together. And he says, well, if the planets move in these ellipses, and a parabola is a sort of half of an ellipse, then we can say that the planets are really falling bodies that never manage to hit their targets, right? The same force then that makes the apple fall from the tree is the same force that must then be causing the planets to fall perpetually around the sun. They just never hit it. But he realized his equations, and remember he's invented the infinitesimal calculus to work out this motion, his equations indicated to him that the planets, if left to themselves, would eventually crash into the sun. And so he had to have recourse to his vision of a clockwork God who periodically had to intervene and reset the planets so that they would not spiral off into chaos. So we have the vision of the clockwork God, who is the God who is now cast in the role now of a clockmaker. And this is the construction of the mechanistic vision of the universe. And it had been thought in the Middle Ages, recall, that the laws of the heavens were different from the laws of the earth. But here we have, it's one set of laws constant throughout, namely universal gravitation. Is a sort of mysterious force, and nobody really knows, still doesn't know what gravity is. It's a mysterious force that acts upon objects at a distance and becomes weaker the further two objects are away from each other, or the smaller the masses get. And so that's the sort of Newtonian synthesis of all of this, and spells the death knell for the Anima Mundi. Yep.
Just as an aside, you mentioned that the planets are actually, as it were, attempting to crash into the sun. In contemporary theory about the physiology of human bipedal locomotion, one interpretation is that a human being walking is actually in a constant process of falling
Yes.
and rescuing himself or herself at the last moment.
Right. Very nice. Very nice. Okay, so that's now a couple of other important asides here is Descartes. Descartes sort of comes in, recall, and really creates this fusion between the inner world of subjectivity and the outer world of objects. And objects in the outer world are all dead. Now, we sort of have, with respect to the heavens, we have this movement from astrology to Newtonian mechanics, and then with Einstein to yet another vision, the Einsteinian relativistic vision. We have three fundamental revolutions there for the heavens. With respect to the microcosm of matter itself, we move from alchemy to the atomistic hypothesis, well, we might say chemistry, which is the study of those processes, and from there to quantum mechanics, which comes in about the same time as relativity does. And these are exactly symmetrical revolutions. And the atomistic hypothesis had been recovered as during the 15th century, along with Plato and Plotinus and all of these others, Ptolemy, when Lucretius's De Rerum Natura on the nature of things was translated. And recall that alchemy had been based on Aristotle's vision of the four elements. Well, that's incompatible with an atomistic theory of matter. It doesn't, the two don't map on very well. And when that theory came in and began to become popular, Descartes picked it up, and Hobbes picked it up, and Francis Bacon picked it up. The British and the French in particular really grafted onto it. And when that happened, the sort of ontological rug was pulled out from under alchemy. It could no longer work.